Hello everyone, welcome to the final presentation video of Smart Road Collision Detection and Notification System. My name is Mihang Amarasekara and my team member is Rashmi Sandaruni. In this video, we will be discussing about the problem identification, objectives, research questions, product components, parameters considered to detect an accident, determining the level of crash, and at last the demonstration video. Along with the gradual increase of the number of vehicles, the most discussed problem among the society is the traffic congestion caused by it. But apart from that, this has also led to the increase in the number of vehicle accident deaths. Vehicle accident deaths and injuries are too common nowadays. Vehicle accidents are among top 10 global causes of deaths from years 2000 to 2016. Apart from deaths, millions are suffering from severe injuries, spending the rest of their lives with disadvantages. Road traffic collisions are one of the main reasons for deaths of people aged between 15 and 29 years. Even though some of these accidents occur due to unavoidable reasons, many of these accidents occur due to careless human errors. It is the 9th leading cause for deaths and has aimed to rise to number 7 by the end of year 2030. One of the main reasons for these tragedies is the delay of the medical services. A previous study has also shown that reducing the response time by 60 seconds has led to increase the number of lives saved by 6%. As this study shows, the response time after an accident is extremely important when coming to saving the life of a victim. Therefore, the main objective of this project is to send help to people who are helpless after an accident by providing them with the required emergency medical services as soon as possible. Before coming up with our proposed solution, we had to find mechanisms to overcome the following research questions. How to reduce the time taken for the emergency services to respond after an accident, how to recognize the location of the accident accurately as possible to make sure the emergency services are directed to the correct location, how to store important information about the accident so that it can be retrieved later when required. In order to build this system, we have used the following product components. We have used two Arduino Nano boards, one GPS module, model number Neo6M, one GSM module, model number SIM800L, 4 proximity sensors, an accelerometer and gyroscope sensor module, model number MPU 6050, and one limit switch. In order to detect the accidents accurately as possible and to reduce the number of false positives, we have used 3 parameters in this implementation. The parameters are the distance between the vehicle and the obstacle, the angle of the vehicle, and the deployment of the airbags. The distance between the vehicle and the obstacle is sensed by the proximity sensors. When an obstacle is within the field of the proximity sensor, it will be detected. Angle of the vehicle is detected by the gyroscope and the airbag deployment is detected by the limit switch, which we have placed in the vehicle's dashboard. After detecting an accident, the system will identify this as either a high severity collision or a low severity collision. If the accident is only detected by the proximity sensors, it is low severity. If more than one parameter is detected by the system, it will be considered as a high severity collision.
This is the prototype of the Smart Road Collision Detection and Notification System. And in our device, we use 3 parameters to identify whether a collision has occurred or not. And the first parameter was to identify the distance between the vehicle and the obstacle. And for that purpose, we used 4 IR proximity sensors. There are 2 proximity sensors at the front and 2 at the back of the prototype. To test the first parameter, we will collide it against an obstacle, and in here, when this happens, an interrupt signal will be generated from the IR proximity sensors and will be sent to the IoT platform Blink, and the screen recording of that will be shown next. The second parameter that we considered in identifying a collision is the angle of the vehicle, and for this we use the MPU 6050 accelerometer plus gyroscope sensor. This sensor will be placed on the dashboard of the vehicle since it needs a flat surface, and from this parameter we can identify whether a vehicle has been toppled or not, and it is also important in identifying the severity level of the accident as major or minor. And when an interrupt signal is generated by the sensor, once the vehicle has been toppled like this, it will be sent to blink, and from there we'll be able to see the location, time, date, and also the license plate. The third parameter that is used to identify whether a collision has occurred is the deployment of the airbags, and for this we have used a limit switch. And by finger flicking we tested it, because when you finger flick on it, the force that is exerted onto the limit switch is much lesser than what will be exerted in case if the airbags deploy, and this will be actually fixed under the dashboard. And this is not usually in the normal closed state. When it is triggered, it will send a signal to the blink indicating it as a major accident.
Along with the demonstration video, we have come to the end of our final presentation. Hope you enjoyed it. Thank you.